So, welcome to today's live discussion session. So, today's discussion session will be our penultimate discussion session for this course. That is our 11th week discussion. Today, we will be mostly discussing solving problems on our earth pressure theories, which we also solved in the previous week. So we will be solving some problems on the earth pressure theory. And apart from that, we will be solving problems from the change in stress at a point in soil. So that topic was actually taught in the 11th week. So we will be covering those two things this week. So the stress beneath the soil, that thing actually is nothing but see, we already used that thing, right? That 2:1 method we already used in consolidation chapter to determine the stress at a point due to say footing is placed. Okay, so we distributed the load in a 2:1 trapezoidal fashion, and then we determined the stress. So apart from that, so that was a very like raw kind of thing, right? So raw assumption. But what if we actually take into consideration the Hooke's law and everything else? Then how actually the stress changes at a point in the soil mass due to an external load over the soil. So that thing actually is given by was discussed in the stress distribution topic or the stresses in soil topic. We will be solving some problems from that part. Okay. So we discussed, we solve the problems using the Rankine's theory, right? So we discussed what was Rankine's theory. So there are various assumptions made by Rankine that the soil bed should be actually the top of the soil backfill is actually plane, right? Not inclined. Then there is the wall is actually smooth. That is, there is no friction between the soil and the wall. All those assumptions were actually there in the Rankine's theory, right? So Coulomb actually modified that theory by introducing various factors like uh, say inclination, okay, inclination of the retaining wall, then the inclination of this backfill, right? Inclination of this backfill, and also there is a friction, okay, friction between the soil and the wall. So all these factors actually Coulomb introduced, and this actually gives us a more generalized theory, right? So he gave, and based on that theory, the values of the modified values of our K and Kp were actually derived, and those we can also use if you want to use the Coulomb's theory. Right? Okay, so we'll see if we can solve one problem or two problems from Coulomb's earth pressure theory by using the modified K and Kp formula, that is the modified earth pressure coefficient formula. So we'll see that. And then we had the stresses in soil topic. So the stresses in soil, these topics actually comprises mainly of two theories. That is our Posennik's theory, and my Westergaard theory. Right. So these two theories were given by two researchers, Posennik and Westergaard, where they gave some formulas using which we can determine the stress at a point in the soil due to say point load, due to line load, due to a strip load. Okay, so due to various loads coming on the soil layer, what will be the increase in stress at a point beneath the soil mass? Okay, beneath the ground level at any point in the soil mass. So those things we can actually try. Okay. So there are some assumptions of Posennik's theory. I will just read them. So the assumptions are: the soil is assumed to be homogeneous, isotropic, and semi-infinite and elastic. That means the soil is homogeneous, right? Homogeneous, It's also isotropic and semi-infinite. Semi-infinite means it's just uh, like limited in this vertical direction. The soil is actually limited. Otherwise, in all the other two directions, this lateral direction and this out of plane direction, the soil is actually infinite. So it's called infinite. Also, the soil is elastic. Hooke's law is also valid, and the self-weight of the soil is neglected. Okay, while determining the implicit pressure at a point. Also, the soil is initially unstressed. That means there is no previously existing stress. So, also, one more important assumption is that the soil is actually considered as incompressible. Okay, there is no volume change occurs in the application. Okay. Uh, okay. So similarly, there are also some assumptions of Westergaard's theory. So Westergaard also assumed that the soil is homogeneous, in semi-finite, and elastic. Okay, but our bosonics theory actually said that a soil is isotropic, right? Isotropic. But Westergaard's theory said that a soil is non-isotropic. Means the properties change as we change the direction. Here in Westergaard's theory, what happens? Our soil is actually considered as laterally reinforced. That means in lateral directions there is no strain, right? So the Poisson's ratio in horizontal direction is actually zero in case of Westergaard's theory. Okay. So the soil is considered rigid in the horizontal direction, and it is considered elastic in the vertical direction. Okay, in Westergaard's theory. Right. So we will directly start solving the problems now one by one. Okay. So I think we have 17 or 18 problems for today. So we will start solving. So initially we will be solving some problems from our earth pressure chapter. So simple problems and some little bit difficult problems from earth pressure chapter. And then we will be solving some problems from this stresses in soil topic. Okay. Okay, so let us see our first problem. A cohesionless soil with a void ratio of 0.6 and G is equal to 2.65 exists at a site where the water table is located at a depth 2 meter below the ground level. Okay, assume a value of coefficient of earth pressure is equal to 1.5. Calculate the earth pressure interest. So this is very easy actually. So first see, so there is a water table is located at a depth of 2 meter. Okay. First, let us calculate the. So, what is the formula for dry unit weight? G into gamma W 2.61 plus 0.6. So, please calculate this one. The dry unit weight. Let us see how much it is coming. And also, let us calculate the saturated unit. So, please calculate these two values, and then finally the. So, okay. Please calculate. So 0.65 and will be, I guess, 60. This one will be 90. Okay, so now so the total height is actually 5, not given here. 5. So you have something. So here we have 2 meters. Okay. So from here to here we will have some. What will be this? K naught into
Gamma.
2 into gamma dry. Yeah. And from for the bottom part it will be K naught into 3 into gamma sub, and no, another portion will be coming here. This K naught into how much?
K naught into gamma D into 2.
Yeah.
Plus water pressure.
Plus this gamma W into 3. Right? So let us calculate. Say this one is 1, 2, 3, 4. So let us calculate P1 first. So half 2 square. So half that is K naught is 1.5. Sorry, 0.5. It should be 0.5. To gamma T, we calculate gamma T 16.25. To square. Okay. T2 will be okay. So please calculate this P1, P2, P3, and P4. 5 into 16.25 into 2. How much will it be for 1 K naught into
16.25.
16.25? Yeah. Then P2,
740.025.
P2, so high.
16.25.
This one, no? It should be gamma sub here. 10.12. Half into 0.5 into 3 into 10.12. 22.779 pt. Please check once. 40. Not into gamma t.
Right.
Right now, 9. 44.4.
39. Yes.
So total will be, if we add all this, 16.25. Please check the values once, okay? Are these okay?
Yes.
Okay. Okay, so now let us find that point of application of y value. Y will be 16.25
Into 3.66.
16.25 into 3.6. Okay, 16.25 into 3 plus 2 by 3. Then next one, 22.77 into
1.
7 into 1 plus 48.75 into 1.5, right? Yeah, 48.75 into 0.5 plus 44.14 into again 1 by 31 point. So how much will it come?
1.51.
Okay, 1.5. Yeah, yes. Yeah. Okay. Okay, the next problem is for the retaining wall drawn below, plot the passive pressure distribution, passive thrust, and point of application of the scissor. So I will just draw the Okay. So, and water table is actually here. Okay. So first, for see, let me write this as layer A, B, C, D. Okay. So layer AB. For layer AB, what is my KP? KP1 say 1 minus sine 35 degree by 1 plus sine 35 degree. So how much will it be?
It will be opposite. Now 1 plus sine phi upon kp
Yeah,
will be
sorry, say 1 plus. Correct. 1 plus. Yeah. So how much will it be? 3.69, I think. Right? For layer BC, how much is KP? 1 plus sine 25 by 1 minus sine 25. 1 plus sine 25 by 1 minus sine 25.
0.46.
How much?
2.46.
Okay, 2.46. 2.46. And for the last layer CD, I have KP3, it will be 20 degrees. No?
2.
Okay, 2, exactly 2.
2.04.
0.0. Okay, now see water table is here. Okay, at 3 meter below. So now very easy. Let us just draw one by one how the pressure distribution will vary. So okay, so for the first layer, it will be nothing but like this. How much will it be for the first AB part? Right. So KP1 into 3 into 17. Right. So what is KP1? 3.69. 3.69 into 3 into 17. What is how much is this one? This one is also
188.2.
3 meter. Okay. Okay, we will do that. Then for next one, for next the next layer, my phi is changing again. Right. So and it's also submerged. Okay. Please pay attention that it's submerged also. So one part we will be getting from the this overburden, right? 17 into 3. So this is so in the lower part, first we will be getting this. So it is nothing but 17 into 3 into how much? What is my KP2? 2.46. Right? This will be one part, and what will be the other part? 2.46 into 3 into what is the submerged unit weight? 20 minus 9.81. 20 minus 9.81, 10.19. Okay. And then also water. Right. So it is nothing but 3 into 9. Fine. Is it okay?
Okay, fine. But upper pressure
This
3.69
one.
into,
This one, huh?
yeah, pressure from
3.6. Hmm.
that rectangle portion,
Hmm.
this pressure into again this phi value will be there. Means 3.69 into 3
This one.
3.69
3.69 into 3.
into 17 into 2.46.
Why?
Because this pressure now we transfer with another Kp.
Yes. So what is the vertical pressure? At this level, what is the vertical pressure? Vertical.
Right. My mistake.
See, previously also we did same thing, right? Here, see,
Right.
gamma into 2. Yeah. So that is transferred. Okay. So the next, again, the lower part also we have to do now. So here we have 4 meter. So now again this thing will come. What will be this? This will be nothing but see 3 into 17. 3 into 7. Wait, let me write it here. 3 into 17
Into 2.0.
plus. No, just not that. 3 into 17. Then we have again. See 3 into 20 minus 9.81. 10.19. Okay. This total into 2.04. Right, because above that there are 2 layers, right?
Right.
Right. Then we will have this, which is nothing but 4 into 20 minus 9.81, 10.19 to 2.04 plus 4 into 9. Okay. So now let us add all these things. Let us number 1, 2, 3, 4, 5, 6, 7. Okay. So let us add all these things and find out our P, total P. Before that, let me write this separately. After that, it will be difficult to easier to calculate. So what is P1? 3.69 into 3 into 17 into 3. How much?
282.3.
Okay, 282.3. Okay, then P2, 17 into 3 into 2.46 into 3. 376, I think, 0.38.
125 point.
Hmm?
Yeah, again height will be there.
Yeah. Then P3, half into 2.46 into 3 into 10.19 into 3. 112.80. Then P4, P5, Please check the values, okay?
Yes.
If you don't get anything same, please tell. P6. Just a second. 3 into 17 plus 3 into 10.19 to 2.04 into 4 also is there. 6. 65. 6 into half into 4 into 10.9 into 4 into 4. So it's only 166.3. Last P7 is 54. 78.40. Okay, so total by P will be 82.3 plus 1726.0. Check this value once. I think it's correct only. 1726.02 kilonewton per meter.
Right.
Okay. Okay, so we have done the difficult part, and now just we need to determine the point of application. That's all. So y will be, so let us see, 282.3 into 282.3 into how much? 478, right?
Right.
8 plus 376.38 into 3 by 2 is 4 plus 1.5, that is 5.5. 5.5 plus 112.80 into 5. 112.80 into 5 plus 3. You got 3. How much done? 1, 2, 3. 3 done, right? Now P4 is 44.15. Same. 44.15 into 5 plus 665.61 into 2. 665.61 into 2 plus for this one we have 116.3 to 4. Yeah, 116.3 to 4 by 3. 6.3 to 4 by 3 plus last one.
It's a
So
160.3.
which one? Which one?
It's one.
One how much?
166.
Oh, 166. Okay, sorry. And last one is how much? 78.48 into 4 by 3. Total divided by 1726.02. Okay, so this should come close to 4, I think.
Yes, 4 meter approximately.
Okay. 3.9.
0.92.
Okay. So almost 4 meters. Okay, so the problems are actually easy. These problems, we have nothing but just we have to like while we multiply everything, just we have to be like very careful and nothing else. Otherwise, it's nothing. Just multiplication, addition, and division. All that. That's all. Not that tough. Problems are easy. Just we have to be like very careful while we are taking the whole like while you are considering the work burden and all these things, and while doing the multiplication. That's all. Other than that, nothing is there. Okay. Okay. Now, next problem. A 5 meter high vertical wall supports a saturated cohesive cell. Okay, means phi is equal to 0 with a horizontal backfill. The top 3 meters unit weight of 17, C is 15, bottom meter. Okay. If tension cracks have developed, then what would be the total active thrust? Okay, so active thrust you have to find out. So we have a retaining wall. Okay, so this one is 3 meters, this one is 2 meters. Gamma is equal to 17. C is equal to 15. So A to C is okay. So what will be my K
1
for
minus
both? 1 minus sin phi by 1 plus sin phi. Phi is 0. So what is K? 1. Right. So both the layers, my K is 1. Right. Now, what is the actually what is the equation of our active thrust? Is nothing but K into gamma Z minus 2IC root over K. Right. So here what is it given is that if tension cracks develop, okay, means tension cracks have developed, right? So let us first draw for the upper layer. Okay, so let us first find out the depth of tension cracks, Z naught. Okay, so depth of tension cracks is given by 2IC by gamma root over K. Okay, so K is same equal to the 2IC by gamma, right? This is nothing but 2 into 15 by what is gamma 17. It is 1.76 meter. So depth of tension crack is this much. Now, just a second. Let us draw this. That will be clear. Okay. So upper part is how much? 3 meters and below it's 2 meters. So it will be something like this. Something like this. So this is how much?
1.7.
1.75, 1.76, 1.76 meters. Okay. This minus, this is plus. What is this value?
2C.
Yeah, 2C root over K means 2C only. Means 2 into 15, 30, right? Right?
Right.
K is 1. So 2 into C means 2 into 15, C is 15, so 30. So this is my 30K. Okay. So now at a depth of 3 meter, let us see. This one will be how much? What will be this one? This is 3 meter, right? What is this one? So 1K into
3 minus
3 into what is the gamma? 17. 17 minus 30.
Right.
right? So what is the value? 17 into 3 minus 30, 21. Right, 21 kp. This one. Okay. So now let us come to the lower portion. Okay. Now coming to the lower portion. Now see, now let us again see that due to the overburden, this straight thing will be coming. Right. So at this point, so my k values are actually same. Right. So k value is actually same, but this at lower layer, so let me write that. For lower layer, lower layer, what is my, so PA, this is my PA. PA is same K2 into gamma into Z minus 2IC root over K2. So this is 1, this is 1. Okay. Now, due to the overburden, so what is the overburden here? 3 into 17, 51. 51 is the overburden. So 1 will get something like this here. So this one will be, sun is 4, 2 meter, 2 meter. So this one will be how much? 3 into 17 into K2. But what is the K2? K2 is 1. This is 1. So this will be getting here. This is positive. This much we will be getting. And apart from that, the other part that we will be getting is from this equation. This gamma into Z minus twice. Gamma Z minus twice C. Right? So at Z equal to 0, we have so at Z equal to 0, how much we have? Where to draw? I will do here only. So when Z is 0, here, what is the stress? What is the PA? Can you tell me at this level?
Due to
For the lower layer only. For the lower layer only.
0.
For the lower layer.
Triangular shape.
Yeah, minus twice C, right? At the top, minus twice C. Right? So minus 2 into how much? 22.5. 22.5 into 2, it is 45. So minus 45 here. Right. So this much is minus 45. This one is minus 45 kPa. Right. And what will be here at Z when Z is equal to 2 meter? How much will be the value when Z is equal to 2 meter using this gamma? What is gamma? Gamma is 19.2. So 19.2 into 2 minus 2 into 22.5. That is minus 6.6. So it will be something like this. This is total minus. This is 6.6. So is this clear?
Yes, yes, clear. There will be
Yeah.
no again Z naught in.
No Z naught.
Right.
Right. So this much will be the this will be our diagram. Now what we have to do is that we have to just find out the total P value. Okay. Okay, let me just check once. PA1. Okay, so here we have what is given if tension cracks have developed. Okay. Tension cracks have developed means only this portion. So this upper portion won't be coming, right? So we will be just considering this portion, this and this. This we won't consider. Right? Tension cracks have developed. So this portion won't be coming into the picture. Right? So please find out the area of this triangle. This is 1, this is 2, this is 3. So what is P1? Half into 21 into
6.6 value.
3 minus 1.76. How much?
6.6 value. How came?
This one, see, gamma into z, that is 2 minus 2 into 22.25. How much? 22.5. This is 19 point. It's given, right? For the layer to this, 19.2.
Okay.
19.2 into 2 minus 2 into 22.5. Okay. This. Okay, now? Okay, so let us see how much P1 is coming. Half into 21 into 3 minus 1.6. 13.02 kilometer per turn. This P2. 3 into 17 into 2. 102. P3. What is P3? How much will be P3?
0.6 plus by 2.
Area of that trapezium will be minus 51.6.
Right.
So total P will be how much? 13.02 plus 102 minus 51.6. 63.42. Okay. Now can we find out the point of application? This Y. Can we find this Y? Nothing, same. Okay, so first is
13.25.
this triangle. Yeah, how much? 13.02 into 13.02 into 2 plus 3 minus 1.6 by 3 plus 102 into 1 to 1 plus minus 51.6 to this center of the trapezium. It will be actually 1.24. Okay. Okay, divided by 63.42. Please calculate this one. So the centroid, I will just find it here. 6.6 plus 2 into 45. And 3. So how much will it come?
3.28 meter.
2.28. 0.02 into 2 plus 3 minus 1. 1.09 I am getting. 1.09 meter. Check the multiplication once.
It's coming 1.26.
0.26. It should come 1.09. I am also getting 1.09. 3.02. 24. I'm getting 1.09 only. It's okay. The little difference, you can check this later. Okay. Okay. Let us move to the next problem. A smooth vertical back retaining wall of 4 meter high is pushed against soil with friction angle C and phi are given and unity is given. Find total lateral thrust if horizontal thrust carries surcharge of 6 kP. Okay. So it carries some surcharge also. Okay. So 4 meter high. So 4 meter high. Okay. Soils, phi soil is given and we have a surcharge here of 60 kP. Okay. So this is the case of active pressure or passive pressure. Can you tell me? This is the case of active pressure or passive pressure? On the question.
It's a passive.
Yeah. Why? Because it's pushed against the soil, right? So the passive pressure will be mobilized. So let us find the Kp. What is Kp? 1 plus sine 20 by 1 minus sine. How much? Same 2.04. Okay. So we have Kp. Now what is my P? P? It's Kp gamma z plus 2IC root over Kp, right? This is the equation for the passive pressure. First, for the due to this 60 kPa, what will be the passive pressure? Due to 60 kPa, you will be getting this is nothing but 60 into my Kp, right? So this is 1. Now what we can do, this 2IC root over Kp, this we can consider uh, as one surcharge, say, yeah, due to C component, one constant pressure. Okay, so due to this, we can see that we can make another this triangle. This is 2. This will be 2IC root over Kp. Okay, and then the last one is nothing but this variation for the this part. Kp comma 7. So how much is this 60 into Kp? 60 into 2.04. 60 into 2.04, it is 122.4. This one will be 2 into C is how much? C is 20. To root over 2.04, 57.13. And this one is 2.04 into gamma is 19.2 into 4, but 156.6. KPA, KPA, KPA. 3. So what is P1? How much?
4 into 122.4.
Yeah. 4, 489.6. P2, 57.13 into 4. So it's 228.52. And then we have P3. It is half into 156.67. 313.34. So we have PS 489.6. Right, done. Just now we have to find out this capital P. Let's find this out. Sorry. Again, I am doing mistake. 228.52 into 313.34 into 3. Okay. So let's see how much this one is coming. 489.6 into 2 plus getting 1 point, almost 1.8. Check it. Yeah, I'm getting 1.79. Check this value once. If it's coming 1.79.
Right.
Okay, no? Okay then. Let's go to the next one. Okay. So a 5-meter high retaining wall has a granular soil with a level top. Okay, so the top is level. The retaining face makes an angle of 85 degree with the base. Unit weight is 16. Okay, phi is also given. Delta is good. This delta is actually the friction angle between the wall and the soil. Okay. Calculate the active thrust using Coulomb's. Okay. So this is actually given to us. Okay. So this is the theta degree. This is given to us. This is 85 degrees. Okay, so this theta will be nothing but 180 minus 90 plus 85. Okay, 5 degree. My beta is 0 because my soil is level. Okay, the soil is level like this, not inclined. So beta is 0. My delta is 10 degrees. My phi is 30 degrees. Okay. Now we have to find out K. So what is the formula for K using Coulomb's method? Nothing but sec theta cos phi minus theta divided by big formula root over cos theta delta plus root over sin delta plus theta sin phi minus theta by cos theta minus theta. Okay, and square of this. So what you have to do now, you have to put now all the known values and find out k. So please put carefully all the values of theta, phi, then delta, beta, everything, and please find out k. Okay, and don't forget that this whole thing is squared. Okay, so let us see how much k we are getting.
Value coming very 3.6 into 10 to the raised minus 3 almost. Something I made mistake, I guess.
Yeah, it should come around 0.2 only because see 1 minus sin phi by 1 plus sin phi it's 0.27. So it should come near that only.
Yeah.
Okay. Okay. Sine delta span.
I think I'm making some mistake. I'm getting very high value. Yeah,
Okay,
very
okay, okay. Here, whatever it is given, it's actually 2.88. Okay, so it should be around close to that only, 2.7. between 2.7, 2.8, something like that.
This formula is same as that of sine square of alpha plus phi divided by sine square of alpha into
Yes,
sine.
yes, same only, same only. Just here alpha is nothing but 90 minus this theta. Okay. That's all. Mm, theta. Okay. Okay. Let it be. So what will be P? P will be nothing but gamma K h square. Okay. So this H is okay. So whatever comes will come. Okay. Let us go to the next problem. A vertical wall h equal to 7 meter is having cohesionless soil. Okay, at the back, having saturated unit with this much 5. Okay. Cohesionless means C is equal to 0. The water table behind the wall is 3 meters below the top. The top 3 meters soil is also saturated with capillary moisture. Find the total thrust and the point of application. Okay. Okay. Last. Okay, so our wall is actually like this. Comma 7. Here water is there. Okay. So how much is K? 1 minus sine 35 by 1 plus sine 35. Think about 0.71. Okay. Now, see. Okay. So upper portion is also heavy saturated in it. So for here, it will be nothing but normal as usual. Okay. One, this is nothing but 22.5 into 3 into 0.2. Okay. And then we will have in the lower portion this thing
top layer is moisture also saturated due to capillary moisture.
Yeah, 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 yeah. So just due to the capillary action, the our this it is just saturated till the top, nothing else. Okay, the what soil there is just saturated. That's all.
There is we don't need to consider negative capillary action force.
No, we won't consider that because we will see will actually will ignore that the tension due to this capillary negative force. We will actually ignore that. Okay. So we'll draw that again in the side. Let us first finish this one. We will draw this whatever we are saying. So it is nothing but how much will be this? 22.5 into 3 into K, right? And here we have our submerged soil, which is 22.5 sin 0.81. 12.69 into 4.5 into 0. Okay. Now, due to the water, actually, we will be having. Just a second. Yeah. So in this part, we will have this positive thing. It was 9.81 into 4.5. And in the upper portion, actually, this negative part is there. Okay, this negative, this value is not also same 9.81 into 3. Okay, this is there, but what we are doing is that we will be actually ignoring that part because it does not, this capillary force which is exists is that actually does not what it actually does not cause any cracks in the soil. So we'll take that assumption and we will ignore that part. Okay, so let us calculate P1. T1 is the area of this triangle. So 22.5 into 3 into 1.7, 54.87. This P2, 22.5 into 3, 127, 2.5, 2, 4.5, 2.32. Okay. P3 will be okay. So then just we will be summing all these up to find out the total. Three zero six. Okay. So please check this one. Okay. All these values once. I will also check once. writing 20.271 into 22.5 into 3 to 3 to 3 27 it should come out. Yeah, it should be 27, no? 27.44. Okay, P2 is fine. P3 34. P3 also I made some mistake, I think. Half into 12.69 into 4.5. 34.82. See, it should be 34.82. Okay, the last one is fine. So total will be 243.9. Okay, then similarly you can find out our y, pi, yi by summation p, total p. You can find out y. So it will come out as 2.2. Just okay. Okay. So just a second. Returning. Okay, let me just do one thing. Let us just solve some problems from that second topic, because if I keep on because it's already almost 7:30. If I keep on, we will let us keep these problems for the next class. Okay, so we will solve some more one or two more problems from this earth pressure in the next class. Today, let us start solving some more problems from our this earth pressure, not the stress in a soil chapter. Okay, but I think only this problem, seventh problem, and this eighth problem. Okay, these two problems I will solve in the next class. Okay, the seventh problem and eighth problem I will solve in the next class. These are good problems. So these two problems I will be solving in the next class. Yeah, it's quite big, long also. The problem is quite long also. So I will solve this seventh problem and the eighth problem in the next class. I will write here. Okay. Yeah. Okay. So let us solve some problems from this chapter. That is our stress beneath the soil chapter. Some problems let us solve. Easy problems we will be solving using the bosonics and our Westergaard's theory. Okay. So the first problem is that a concentrated load is there. This is the ground surface. Okay. And the concentrated load of 2,500 kilonewton is acting the ground surface. We have to determine the vertical stress at a point P at a depth 5 meter. Okay, so at a depth 5 meter and horizontal at a depth of 4 meter on the square. At this point, we need to find out. Okay, so if this is 5 meter, then this is 4 meter. Also, we need to calculate the percentage increase in stress when the point P. So when the point P is directly here, we need to determine the increase in stress. So can you recall what is the formula given by our bosonics theory? It's nothing but 3q twice by z square 1 by 1 plus r by z square. Okay, and what is our q? Q is nothing but 2500. That what is z? Z is 5 meter and my r is actually 4 meter. Okay, I will just directly put the values 3 into 2500 by twice pi into 5 square plus 4 by 5 square by 2. Okay, so if you do this, please see how much it's coming. It should be 13.86 per meter square. Okay, now when r is equal to 0, so p point is shifted here, means by 4 r becomes 0. So if r becomes 0, so let us see how much it's coming. R equal to 0, my sigma z will be 3.2500 by 2 s prime to 5 square by 1 by 1 plus 0 by 5 squared by 2. This will be 47.7. Percentage increase, nothing but 27.75 minus 13.86. 6 into 100% will be around 244.2%. So lot. Okay, just if we shift 4 meter laterally, see your stress is actually reducing by almost 250 times. Okay, so my stress variation is actually like this. Okay, so the center it's very high and the sides it's very low. Okay, center it's very high, the other sides is actually very low. So this is the distribution. Let's go to the next problem. Two columns A and B are situated 6. So two columns are there, just situated 6 meters apart.
Just show that percentage increase.
Yeah. Okay. So almost double, more than double. No? So two columns are there, A and B, situated 6 meters apart. Column A transfers a load of 500 kilonewton and column B a load of 250 kilonewton. Determine the resultant vertical stress on a horizontal plane 20 meters below the ground surface and at a point vertically below the point B. That means this is our ground surface. Okay. So there are two columns, column A and column B. So this is giving 500 kilonewton. This is giving 200 kilonewton. Now we need to determine the vertical stress on a horizontal plane 20 meters below the ground surface. Okay. So if we take, say, DC axis here, like this. So we need to determine here, say the point P. Okay. For point P, the point P is situated 20 meters below. Okay. And this is from here to here, this is how much? 6 meters, because this is situated 6 meters apart, right? A and B two columns are situated 6 meters apart. Now, how to do this? So now let us first find out the effect of this 500 kilonewton load on this point P. Okay, the effect of this 500 kilonewton on this point P. Right. This one, we will use the same formula. By Z square by 2. So Q is now 500. Okay, but what is Z?
20.
Yeah, 20. 20 square. 1 by 1 plus what is R?
6.
6. 6 by 20 square by 2. So please calculate this one. It will be quite less only, not that much. How much?
6.2.
6.2. Let me check one. Sweet. 6. 6 square by 20 square. So
Something wrong, right?
0.4 should be 0.48. Okay, it's coming 0.48 kilonewton per meter square. 481. 0.481 kilonewton per meter square. Okay, so this was the effect of this 500 load on at the point P. Now let us find the effect of this 250 load on point P. We'll just make some space here. So Z will be again 20, but this time R will be actually 0. 0 by 20 square by 2. So another formula is there. It's I think about 0.477 Q by Z square. So Q is 250, Z is 20 square. So it will be around 0.2984 per meter square. Okay. So the total increase in stress is nothing but 0.2984 plus this 0.481. But 0.7794 per meter square. Okay. Okay. Next is a three-legged tower forms an equilateral triangle in plane of side 3 meters. Okay, so it forms a equilateral triangle at the length of each side is 3 meters. If the total weight of the tower is 450 kilonewton and is equally carried by all three sides, compute the increase in vertical stress caused in the soil by the installation of the tower at a depth of 4.5 meter directly below one of the leg of the tower. Okay. Okay. So I need to calculate the stress increase in the soil below any of the legs. Right. So total weight is 450. So load on what will be the load on each leg? 450 by 3, but 150 kilonewton. Okay, total 450 kilonewton distributed in 3 legs is 150 kilonewton. Now, how are they distributed? They distributed in triangle. Okay, say B, C. So each side is my 3 meters. Okay, tower is there. Now we are to find the vertical stress at any point at below in one of any one of the legs. Okay, say we consider leg A. Okay, so below the leg A, we are finding the increasing stress, right? And what depth below? It's at a depth of 4.5 meter. We need to find it. Okay. Now see, so now due to the load on leg A, what is the increase in stress below A? Let us find it out. Find it out first. So we'll use the same formula: PQ by twice by Z square and by 1 plus R by Z square by 2. So 3 into 150 by twice by what is Z? Z is nothing but 4.5 square by 1 plus what is R? R is 0. So 0 by 4.5 square by 5 by 8. Okay. So please calculate this. Give me a second.
Three point five three.
Yeah, 3.5, 3.5 is actually right. Just give me one second. Yeah, 3.53 is correct. 3.53 kilonewton per square. Now what we need to do is that due to this loaded B and C, what is the loaded A? So those B and C will be equally contributing to this A. So again, I have to make some space. So this will be really contributing nothing but 3 into Q by twice by Z square by 1 by 1 plus. Now tell me what will be R? Z you know. Right. So what will be R? What will be R?
Diagonal.
No. Yes. For the load here, we are finding here. Right. So what is R?
3 meter.
3 meter, correct. 3 meter. So it will be 3 meter. So please calculate this. Then we will be finding the total increasing stresses, sigma 1 plus sigma 2 plus sigma. Plus sigma. What is this coming?
One 1.41.
Yeah, 1.41 kilonewton per. So 1.41 plus 1.41. So total we have 6.35 kilonewton per meter square. Okay, so this is the final answer. Right? Next. An infinite line load of 600 kilonewton per meter exists. Determine vertical stress at a point A with coordinates x equal to 5 meter and z equal to 4. Okay. So a line load exists, right? Finite line load. So if I draw the diagram, something like this. Say if this is my x-axis and say the out of plane direction is my y-axis, then it's something like this. Okay, in this direction, we have a line load. This is 600. Okay, and this is my z direction. This is x. Okay, so the point is actually somewhere here. Okay, the point P. So x is my x equal to 5, z equal to 4. So I need to find out the stress here at the point. So can you remember what is the formula for the stress for this line load? Okay, for the line load, it's nothing but 2q by pi z 1 by 1 plus x square by z square or square. Okay, so we'll directly just substitute this in place of q. We will be putting 600. Six hundred pi into 4 by 1 plus 5 square by 2 square. Okay, so please calculate this. Two into 600 by 4. 14.54 jumper. Okay, so due to this line load at the point P, 14.54 kilonewton per meter square stress is getting developed. Okay. The next problem, two parallel line loads with 1500 kilonewton per meter and 500 kilonewton per meter separated by 5 meters. Okay. Find stress at a point 4 meter below ground level and 5 meter away horizontally from the 500 kilonewton per meter load. So if I draw this the front view, so you have two line loads. This is 1500 kilonewton per meter. And this is 500 meter. So they are separated by 5 meters. Okay, so this is find stress at a point 4 meter below. Yeah, 4 meter below ground level and 5 meter away horizontally from the 5 meter. Okay, so at some point here, 5 meter. Here's a point P, and this is the ground level. This is the ground level. This is 4. Okay, at this point P, we need to find out the stress. Okay, so now let us first find out the stress due to the line load 1500 kilonewton per meter at the point. Okay, so Z1 write it like this. So it is 2Q1 ZQ by pi x1 square Z square square. Okay, so 2 into 1500 into Z is how much? 4 cube pi into x is what will be x? X will be how much?
10 meter.
10 meter. So 10 square plus Z square is 2 square square. So sign this out. And similarly, we will have Z2 2 into 500 into 5 5 square plus 2 square square. Okay. Total Z Z1 plus delta sigma Z2.
Four point 54 and 12.1112.
Okay. 4.54 11. So total will be
16.65.
So a loading of 50 kPa is acting on an annular foundation of width 5 meter and inside diameter 10 meter. Find the vertical stress intensity at a depth of 10 meter below the center of the foundation. Okay. So annular foundation means something like this. Okay. So there is Right. So one circle is there, and okay, like this, something like this. So this is annular foundation, and the width is this width is given as 5 meter. The inside diameter is this inside dia is given as 10 meter. Find the vertical stress intensity at a depth of 10 meter below the center of the foundation. Okay, so below this center, we need to find out the intensity. Okay. So hmm, how to do this? How to do this? Do you have any idea? How can we do this? Okay, this is the foundation. Annular foundation. Okay, this part nothing is there. Like this CD, center portion, nothing is there. Like a ring. How can we do this? So what we can do is we can find out the stress at the center of the circle, below the center of the circular stress distribution of when the circle is having a radius of say diameter of 20 meter. This we can do. So we will have two circles. So diameter 120 meter and one we have 10 meter. Okay, so what we can do is that from the increasing stress due to this, if you might deduct this increasing stress due to this, we will get the final value. Okay, we can get the final value. So let us write this as z equal to q by 1 minus 1 by r naught plus r naught means outer. Okay, square 3 by 2 minus q into 1 minus 1 by 1 plus z. Okay, my q is 50 kPa, r outer is 10 meter, radius of the outer, r inner is 5 meter. Okay, and what is my z meter? What is my z? Z is 10 meter. The depth parameter, right? Z is okay. So please put all the values and find out the sigma. R naught we have, R I we have, Z we have all the values we have. We can just calculate.
Can we use the symmetry and apply the load at the center and find the solution?
Like how?
Can we use the symmetry
Like
of
point
loading?
load, you are saying that we can, if we can, please check, we can check this one later, that how much is it actually coming. It won't be same because a point for the point load, it just below it, and see here there is no stress at directly below this, right? So when a point load will be there, it will be like higher, I think. It will come out higher, obviously.
It won't be same.
Yeah, it won't be same. It will be higher. We cannot actually do this thing. It won't be same. You can check this one once. let us first find this out, then we will check once that thing. Should be around 18 kilonewton per meter square. Yeah, 18.10. Now let us come to that question. Say, so if you want to idealize it that well as a point load, so what is the area of these concentric circles? Say pi r square, right? So pi into 10 square minus 5 square. So area comes out to be 235.62 meters square. Okay. That area into 50 kPa will give you 11780.9 11780.9 kilonewton. Say this much is actually acting at the center. Okay. So what is the the increasing stress is given by 0.477 q by z square. Okay. Now you put q is this value, whatever this 11780, and in place of z you put 10 square. So it will come out as 56 point, almost 56.2 kilonewton per meter square. Okay. So it won't give the same result. It will give a higher value like that.
Thank you, sir.
Okay, so next problem. Yeah, a 2-meter wide strip footing is placed. Determine the vertical stress at a point 2 meter below the center of the strip. Okay, so what is so we have a strip footing. Okay, due to the strip footing, one strip load is there of 100 kilonewton per meter square. Okay, this is actually given in the question. I did not draw that figure, so I'm giving it now. So 100 kilonewton per meter square, this load is coming on the strip footing. Now what we need to do, we need to determine the vertical stress at a point 2 meter below the center of the strip. So this is 2 meter wide. This is okay. So at a point 2 meter below the center of the strip. So say here. Okay. So this one is 2 meter. Here we need to find it out. This is the point. Now, how for a this strip footing or the strip load, the increase in stress is actually given by this q by pi theta plus theta. Okay. So, and what is theta? Theta is actually theta is actually this complete angle is theta. Okay, this is theta. Okay, now let us find this theta by 2, this angle. Okay, half. So what will be theta by 10 theta by 2? What will be 10 theta by 2? Perpendicular by base. What will it be? What will be 10 theta by 2? So like this you have, right? This you have. This is theta by 2. So what is 10 theta by 2?
1 upon 2.
1 upon 2. So what will be theta by 2? Tan inverse 1 by 2. So my theta will be 53 degrees, 53.13 degrees. Convert this to radian also. 10 into value 53.13 degrees. Okay. Or how many radians? So 180 degrees pi radian. So 1 is pi by 180. So pi by 180 into 53.1. So how much? 0.9?
1927.
0.927 radian. Okay. So my sigma z will be q by pi. Q is 100 by pi to 0.927 plus sine 53 point. Okay, so this will give the result by pi to 54.97 kilometer per. Okay. Yeah. So now we will be solving the last problem for today. Okay? Yeah. So we need to calculate the intensity of stress at a point located at depth of 2.5 meter. Depth is 2.5 meter due to a load of 2 kPa over the footing area of 4 meter into 5 meter. Okay. So just a second. Just a second. It should be 250. Okay. So we have a footing like this. Okay. So this is, so it's 4 meter by 5 meter. And we are to find the stress beneath the point P, and the point P is actually located here. This is the point. So below this point, we need to find the stress. This is 2 meter. This is 2 meter. This is 2 meter. This is okay. So below 2.5 meter below this point P, say this one is the plan B. Okay. So below 2.5 meter below this point P, we need to calculate the stress due to this 2.250 kPa, which is spread all over, distributed all over this footing. Now let us give some names to these areas. Okay, so 1, 2, 3, 4. Okay. Now for area 1 and 3, for area A1 and A3, my M is nothing but L by Z. L here is 2, Z is 2.5, so 0.80, and N is P by Z, same, also same, 2 by 2.5 equal to 0.6. Now for area A2 and A4, M is L by Z, so 3 by 2.5, which is 1.20, and N is B by Z. B is 2 by 2.5. Okay. Now we have our Bosenics. From the Bosenics equation, what we can add? We can get this K way. K is nothing but 1 by 4 pi big, okay? Is mn m square plus n square plus 1 by 2 pi m square plus m square plus 1 into m square plus n square 2 m square plus 1 plus tan inverse twice m square plus n square plus 1 m square plus minus m square plus 1. Okay, so very big expression. So K1 will be equal to K3, means for this area 1 and 3 those are same, and for area 2 and 4 it will be same, right? So K1 will be equal to K3 and your K2 will be equal to K4, and my final sigma z will be given by K1 plus K2 plus K3 plus K4 into 250. So this will give my increasing stress. Now first let us find out K1 equal to K3. Okay, this we need to find out. So this is quite big, right? This formula is quite big. So what we can do is that you find these things first. Mn m square plus 1 and m square plus n square plus 2. These things, please find these out first. First for this one, for the first one, for A1 and A3, for this one, m and both are 0.8. Okay, m and n both are 0.8. So please put the values and find this out. M and n both are 0.8. So 0.8 into 0.8. Okay. Now what you do, so that there is no mistake, what you do, you find the value of this portion, this tan inverse portion, this angle value you find this out. You find the value of this angle. Okay. Okay, this angle you find this out first. Okay, please do this. Please find the value of this angle. So tan inverse 2 into mn, you already found it out, 0.64 into 2.28 to the power 1 by 2. Okay, then m square plus 1 you already have, 2.28 minus 0.64 square. Just find this out. How much is the angle coming? 45.94, right? Right. So how many degrees? How many radians? Sorry, how many radians?
0.78.
Yeah, or 0.8. Right. 0.8 radians. Okay. So this part we have done. Now we have to do the other parts. Okay, so sorry. Okay. This one you've done now. K1 equal to K3 equal to. Now let us put 1 by 4 pi twice mn. Okay, so 2 into 0.64 into 2.2 root over 2.28 by 2.28 into 0.64 square into 3.28 divided by 2.28. 2 point. How much will it come? How much will this portion come? This portion? How much is it coming?
0.71. No.
7.1? No, I think. Only this part, huh? From here to here. Only this part. Two into 0.64 into root over 0.28, right? Divided by 2.28 plus 0.64 square into 3.28 by 2.28. I'm getting 2.97. Check once, please. Here in the solution, they are getting 1.03. I'm getting 2.97. I don't know. Acha, okay. I got what I did the mistake. It should be plus 0.64. Yeah, it should be 1.03. 1.033. Should be 1.033 plus 0.8. Okay, so it will be nothing but 1 by 4 pi into 1.033 plus 0.1458. Okay. Similarly, this K2, K2 and K4, that also we can find out. Okay, for that you can find out again Mn, then m square n square plus 1, m square n square plus 2. These all these things you can find out. And then again, if you calculate, you will get that your K2 equal to K4, it's coming as 0.1684. Okay, please check this one. Please check if you're getting this. Right there. So finally, my sigma z will be nothing but 2 into 0.1458 plus 2 into 0.1684 into 250. It's nothing but 2.1458 to that. 4 to 3. 1, 157. Okay. And also you can do one more thing. This one, please check if you are getting these values. Okay. Also, what you can do is that you can use Westergaard's formula. Okay, where the k is given by 1 by twice by 14 inverse by twice m square plus 1 by 2 square plus 1 by 4 m square 4 to 1 by 2. Okay. Okay, you can use this relation and also find this given, and also compare the results which is given higher and which is okay. Also, please check this result. So with this, we will end today's lecture. And if you remember that we have two problems left from today's class. Two problems related to our basic charge pressure theories. Okay, so very interesting problems. Those two problems we will be solving next class. In the beginning, these two problems will solve, and then also we will be revising all the chapters from, we will like solving one problem, say one problem each from all the chapters from the beginning towards the end. So this will like sum up the course completely. Okay.
Is
So
there any weightage for calculative or theory portion?
I don't. I am not aware of this thing. This thing. Okay. Like you're asking about the exam, right?
Yeah, yes.
I'm actually unaware of things, how they are going to distribute so did you get the date of the exam and all these things?
Not yet.
Okay,
They had sent one calculator, scientific calculator
yeah,
online.
yeah.
Our regular Casio calculator not allowed.
No, it's not allowed. This calculator won't be allowed in the this examination hall. Okay, so it's an online examination. So it's better that you practice in that online calculator only. These calculators won't be allowed in the exam. So in GATE exam also conducted by TCS-IR, this TCS-IR and digital. So there also these calculators are not allowed. So in the same lines of the GATE exam only, this will be exam is being held. So
And
only the digital calculators are allowed, the on-screen calculators. These external, any electronic devices won't be allowed. This calculator or any other device. Okay, so it's better that so that I don't think that in the exam the calculations won't be that difficult. That whatever will be given in the question, it will be like you will be able to solve using that
And
on-screen calculator.
such a large formula will be given or not given?
I'm not sure. I don't think chances are less, I guess. But when I was in BTech, actually, these questions actually came during our like normal class, like semester exams and all. I remember that we had to remember these formulas. But actually, see, in practical, we don't have to remember these formulas, right? Or this formula is always handy. I don't know about exam whether they will give or not. Chances are less, obviously.
Thank you, sir.
Okay. Thank you.
In
Good night.
exam,
Yeah.
just one question.
Yeah.
There will be solve any 10 question out of 12 like this pattern will be there? Or
I'm not sure. I'm not sure about that. Sorry.
I
because
have
in
given
our
the exam, all compulsory.
all are
That-
compulsory.
all are
Okay.
compulsory. I have given 3 exams. So
Okay.
in this computer type, all are compulsory.
Okay. Yeah. Thank you.
Okay. Thank you.